So this is the third video in 2.4, 2.4c in trigonometry, and like I said in 2.4b, this next video is going to be on the angles of elevation or depression. If we have a horizontal line and we are looking at something up in the air, we are looking up from the horizon, and that's called the angle of elevation. Now, if we are on a cliff and we're looking down at a boat that's down here in the ocean, so there's our cliff and there's our ocean. Sorry, I didn't make blue water. This is called the angle of depression. The angle of depression. Okay, so what we're going to do in order to solve these is, first of all, follow some steps, and one of those steps that's really important is to draw a picture. I always like these pictures. Okay, so example 3, let's do this. Shelley McCarthy knows that, I don't know why they tell you the last name of this girl. Shelley McCarthy knows that when she stands 123 feet from the base of a flagpole. So here's our flagpole. Okay, and we're going to put a little flag here. You don't have to go this detailed if you don't want to, but I do sometimes just because it keeps me from having to actually do the math, so it kind of wastes some time. Anyway, she's 123 feet from the flagpole. All right, so there's little Shelley. Okay, 123 feet from the flagpole. What else do I know? The angle of elevation to the top of the flagpole is 26 degrees, 40 minutes. Okay, so here's Shelley's horizon, which, whoops, I made her a little bit too short. From her eyeballs to the flag, from her eyeballs to the top of the flag, this angle and its elevation is 26 degrees, 40 minutes. That's this angle of elevation right there. If her eyes are 5.3 feet above the ground, so 5.3 is how high she is above the ground. Find the height of the flagpole. Okay, so what we're going to do is we're going to use math, right, like this. We know that's 123 feet, so that's the length of the bottom. We don't know how far it is from here to here, nor do we know this length here, which we really don't care because all we're really asking for is this. So we know that whatever we do, we're going to be looking for this side right here of this triangle. And once we find this side, we still have this much longer of the flagpole to go. So we're going to have to find this side of the triangle and add the 5.3 right there to it in order to find the entire length of the flagpole. All right, so what do we have? We have 26 degrees, 40 minutes, and we have the 123 feet. But the 123 feet is adjacent to this angle that's 26 degrees, 40. What do I know? What trig function do I know that deals with an adjacent? Well, tangent is opposite over adjacent. Cosine is adjacent over hypotenuse. But we had just said we don't care about the hypotenuse. That's not what we're looking for. So we can throw the cosine idea out. What we're looking for is the opposite height. Well, opposite and adjacent are tangent. Tangent is opposite over adjacent. So the tangent of 26 degrees, 40 minutes is opposite over adjacent. So let's write that again. Tangent of 26 degrees, 40 minutes is opposite, and that's what we're looking for. I don't want to put an O there. It makes it look like a 0. Is our unknown, our height of the flagpole, over our adjacent, which is 123 feet. All right, so we have to figure out what the tangent of 26 degrees, 40 minutes is, and doggone, I don't have a calculator, so I can't even figure that out. So find that, and whatever number that is, we'll just put some x's right here, that is going to equal x over 123. And remember, if the variable is on the top and we have a number on the denominator, all we have to do is multiply that number times that number, and that will give us our x. And when we multiply those together, I do know that we'll get 61.8 feet. Well, now we have this length right here, from here to here. Now we have to add little Shelley's height here of 5.3 here. And that tells us that the flagpole is 67.1 feet high. Okay, so not terrible. And let's look at the next example that they give here. Let's jump to example number 4, and I'll get you a picture of that. Okay, so what we have here is we have a length of the shadow of a building. And the length of, or the height of that building is 34.09, and the length of that shadow is 37 feet, or 37.62 meters. We want to know the angle of elevation to the sun. So what we're looking at is this angle right there, because that's the angle of elevation. If we were standing up here looking down, we would be looking at an angle of depression. But we're looking up, so we're looking for the angle of elevation. So that's how we know that we're looking for angle B instead of something up here, like this angle right here. So, given that, we're looking for angle B, so what are we given? We're given the opposite line, because right here is the opposite, and we're given the adjacent. So which trig function uses both the opposite and the adjacent? Well, the tangent does. So the tangent of angle B equals the opposite, 34.09, over 37.62. All right, so once we have that, we can, we can do one of two things. I guess I would divide this first. The book doesn't do that. I'm not really sure why they don't. It just seems kind of silly to write the same thing several times when you can just divide that out and get, let's just get rid of this. I already divided it, and I can divide that out. I've got a little cheap calculator that'll divide just simple things. It won't do tangents or anything, but it'll at least give me that. All right, so what are we looking for? We're looking for the angle. Whenever they're asking you for the angle, you're always going to use the arc tangent, arc sine, arc cosine, tangent of -1. And then you're going to put the decimal here. You're going to plug that into your calculator, and that will give you B. And that will give you, this right here will always give you a degree for an answer. In this case, you get 42.18, or a number similar, or an estimate of that, and that's what that little squiggly equal sign means. So the angle of elevation right here, looking up to the sun, is going to be 42.18. All right, so that is lesson 2.4.